Greetings, scientists. Welcome back to Pattervision. I think you know what time it is. It's time for science! I'm wondering if you're wondering about how many birds there were in last week's video. I know a lot of you tried to observe closely and we had some really interesting claims ranging between only 2 different birds all the way to possibly 57 different birds. You want to know what the right answer is? The correct answer is... I don't know for sure. It was really hard to tell, wasn't it? Sometimes science is like that, and there isn't always a clear answer. Sometimes scientists have to start over and try another way to investigate or gather more evidence. I will tell you this though, the most common claim was 5 different birds. In other words, a lot of your classmates said 5 more than any other amount. That doesn't mean they are correct, but it can help us know that the answer is probably closer to 5 than to, say, 20 or more. We simply need to go back and listen again to gather more evidence. Hello, kids! Mother Nature here, reminding you about structure and function and the beauty that's all around us. Take flowers, for instance. Did you know that all those beautiful colors and patterns on flowers are there to attract pollinators? Pollinators are animals like bees, butterflies, moths, hummingbirds, and many others that spread pollen from one plant to another. This is important because this allows plants to make seeds that will grow cute little baby plants. Aww. Oh, and one more thing. Different colors attract different animals. Did you know that most white flowers are white so they can attract nocturnal or nighttime pollinators like moths? Being white helps to make it easier to see those flowers in the dark. Pretty cool, huh? Well, back to the show. Enjoy that Pattervision with Mr. Corey. Okay, let's get to this week's activity. We're going to continue noticing patterns in nature by observing closely, and then we're going to use those observations as evidence to support our claims. You may remember me using the word argument before. It sounds bad, but in this case it isn't. Engaging in argumentation is what scientists do. We just do it respectfully to try and convince others of our thinking, or we grow our own thinking and consider new ideas. You're going to have a couple of opportunities to make an argument supported with evidence to convince me of your claims, just like scientists do. First, I'm going to give you an example on making a claim about flower colors. Then, I'll get you started on your own. If you get stuck, always come back to this point in the video and use this example to guide you. The documents in the student template will have 2 parts. This is part 1. We're going to look for patterns and see what we notice. This is part 2. Then, we'll take what we observed in part 1 and use it as evidence to convince others of our claim. This is the fun argument part. You're going to make observations and notice patterns from these 12 flowers. For this example, we are going to answer the question of which flower color is most common, yellow, white, or purple. In order to do this, we need to observe closely and see if we notice any patterns. Whenever we can, scientists use math to help us gather evidence. In this case, we are going to just simply count the number of colors. The one with the most will be the one that is most common, at least out of these flowers. Ready? I've made a data table to help organize our evidence. Let's start with yellow. I noticed that A, D, F, J, K, and L are all yellow flowers. I'm going to use tally marks here and mark them down one at a time to make sure I'm being as precise as possible and don't make any errors in my counting. Here it goes. 1, 2, 3, 4, 5, 6 yellow flowers. Next, I'll do the same thing, but this time counting the number of white flowers. I have 1, 2, 3 white colored flowers. Finally, I'll count the number of purple flowers. I have 1, 2, 3 purple colored flowers. Now it's time to use the patterns I noticed as evidence to try and convince everyone of my claim. This is the part where I'll argue how I know the answer to the question. Remember, the question was, what is the most common color of flowers? Yellow, white, or purple? First, we make a claim that answers our question. Going back to our data table, we can compare the different amounts and see clearly that the most common color is yellow. This is our claim, so we will write that down here. The most common color of flowers is yellow. Next, we will communicate the evidence we have observed. This is where all that wonderful math comes in, mathematicians. Even though yellow was the most common color, it is always helpful to compare all the evidence so the person who reads our claim can clearly see what else we noticed. So, we'll make sure we write down all of the evidence here. Out of the 12 flowers, 6 are yellow, 3 are white, and 3 are purple colored. Did you notice how I also included the total number of flowers we looked at? Finally, it's time to share our reasoning. This is a fancy way of saying how we're going to explain our thinking on how the number of flowers we counted supports our claim. In this case, we could say that the evidence shows us there is a greater amount of yellow flowers than white and purple flowers. There. See how it all connects together? Now it's your turn to notice patterns using the same flowers, but I'm going to ask a different question. I know that our second grade mathematicians have been investigating odd and even numbers, so here is our question. What is most common, odd or even numbers of petals? You can find this and the rest of the document on page 2 of your student template in Seesaw. I'm going to get you started by modeling how to look for patterns in the first 2 flowers. Let's begin with flower A. Petals are the different parts of a flower that stick out. So when I look at flower A, I notice that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 petals. I know that 10 is an even number, so I'm going to add 1 tally mark in the section in our data table for even numbers of petals. Now let's look at flower B. At first, it looks like it has 10 petals, but if I observe closely, I notice that the pairs are connected. So I notice that flower B has 1, 2, 3, 4, 5 petals. I know that 5 is an odd number, so I'm going to add 1 tally mark in the section in our data table for odd numbers of petals. That will help you get started. Your task is to finish counting the number of petals on each flower and record it if it's odd or even in the data table. Then, of course, use those observations to answer the question about odd and even numbers of petals to convince me on how you know the answer. You may have already noticed that on page 3 of your student template, I have another investigation for you. This is your challenge if you want to do it and if you want to discover even more patterns in nature. The challenge investigation asks the question of what is most common, flowers on the ground or flowers in bushes and trees? Just so we're clear, this is an example of flowers growing from the ground. This is another example of ground flowers. This is an example of a flower growing in a bush. Do you notice the difference between the flowers blooming from a bush and flowers growing from the ground? Here's another example of flowers in a bush. And this is one final example of flowers growing in a bush too. I think we all know what trees are, but here's an example of a tree in my garden that has flowers. Remember, pages 2 and 3 of your student template might ask different questions, but you can still apply what you have learned from my first example about the most common colors of flowers to help you. As always, I'm super excited to see the different patterns of flowers you notice, and of course, I absolutely cannot wait to be convinced by your arguments. One last thing. Normally this activity would be due next Monday, but since we have a long 4-day holiday coming up, you will have almost 2 weeks to complete this. This activity will be due next Friday on May 29th. Until next time, scientists, have fun doing science!